Hello everyone. In this video, we cover varying annuities. And here, we mainly focus on the arithmetically increasing or decreasing annuity. Consider the increasing annuity due. An amount of k plus 1 is paid at time k, provided that the individual survives at the time of the payment. If this is a whole life increasing annuity due, this is the payment pattern. The individual receives an amount of 1 immediately at age x, and then if the individual survives to time 1, which is at the age x plus 1, then a payment of 2 is paid. The actuarial notation for whole life increasing annuity due, we have IA double dot X, and this equals to the summation, the total of the actuarial present value of each individual payment. The payment is k plus 1, and then the present value factor nu to the power k, the survival probability kpx. And then we have an n-year temporary increasing annuity due. The payment start at 1, and then up to n. This is the last payment when the individual reach age x plus n minus 1. The actuarial present value, the notation IA double dot x colon angle n, and then the summation of the actuarial present value of the individual payments. And we have this expression. For increasing annuity immediate, similar pattern. The annuity amount is k at time k. For whole life annuity immediate, we have the payment pattern. The notation, IAX. This equals to the summation of the product of the present value due to the power k times k, and then times the survival probability kpx. For the n-year increasing annuity immediate, the last payment, the payment of n, if the individual survives to age x plus n. And we have the corresponding notation and the expression for the actuarial present value. All right, and then we move on to the n-year decreasing annuity due. The payments start at n at time 0, and then the payment is reduced by $1 for each subsequent years. So the amount of annuity is n minus k at time k. The actuarial notation for n-year decreasing annuity due, DA double dot x colon angle n, and then the corresponding expression. For annuity immediate, the payment amount is n minus k plus 1 at time k. And we have this payment stream. The notation, DA, and then the expression to get the actuarial present value. There is no need to memorize all these formulas. We just work from the basic principle. All right, some relationships. For the annuity due, if you add up the n-year increasing annuity due with the n-year decreasing annuity due here, you get an n-year annuity due with level payment of n plus 1. Similarly, for the annuity immediate, you add up the increasing and decreasing annuity immediate, you get the n year annuity immediate with level payment n+1. Next, we move on to continuous annuity. There are two types of continuous annuity. The first one, we have an annually increasing continuous annuity. The amount of annuity is paid continuously, and then the rate of the payment is K per year in year K. In terms of the diagram, that is, in the first year, the payment rate is 1. In the second year of the policy, the payment rate is 2. The actuarial notation for annually increasing continuous annuity is I A bar X. And then we sum up the actuarial present value of each payment. Within any given year, the payment is continuous, so we use an integral to get the actuarial present value within that year. So we have the integral. In the case year, t equals k minus 1 to k, and then the integrand. The payment amount or the payment rate is k, and then the actuarial present value factor e to the power minus delta t tpx, and then dt. This is for 1 year. And then we sum up for each year. And this is the actuarial present value for the annually increasing continuous annuity. The second type of continuous annuity is the continuously increasing annuity. The annuity payment is paid continuously at a continuous rate. T, the rate is T at time T. The actuarial notation for continuously increasing annuity is I bar A bar X. And we have this expression, an integral for the actuarial present value. For the n-year temporary increasing or decreasing continuous annuity, if the payment rate is a constant k per year in year k, the annually n-year increasing continuous annuity. So we have this payment pattern. The actuarial present value is given by this. And then for the annually decreasing continuous annuity, the payment rate is n minus k plus 1 in year k. That is, in the first year, the rate is n. And then in the second year, decreases the payment by $1, that is n minus 1. Until the nth year, the payment is 1. The notation, dA bar, x colon angle n, and then the corresponding expression to get the actuarial present value. For the continuous case, the payment rate is continuous at the rate t at time t for increasing continuous annuity. And we have this expression. For the continuously decreasing annuity, the payment rate is n minus t. Starting at the rate of n, and then gradually decrease to 0 at time n. The notation for continuously decreasing annuity is D bar A bar X quotient angle N. And we have this expression for the actuarial present value. All right, and then the relationship. If you add up the annually increasing and annually decreasing continuous annuity, what you get is the N-year continuous annuity with level payment N+1. For the continuously increasing and the continuously decreasing annuity, if we add these two expressions together, this corresponds to an N-year temporary continuous annuity with level payment N. All right, these are the expressions we covered in this video. In the next video, we will do more example on this. Thank you for watching and see you in the next video.